the topmost layer is the application layer. Okay, it consists of compilers, utilities, and user processes, which is launched by any user and other softwares. Okay, so this will be developed by the application developers. They are application developer expert. They are application experts. Okay, it can be in any language. But when it comes to system libraries, middleware developers and system programmers will do the system programming and the system libraries. And the kernel developers does the kernel programming. And yeah, finally the hardware will be developed by the VLSI design guys, and they design the chip, and they will ask the software developers to develop the software for them. Okay, what I'm trying to tell you is, yeah, it is a simple diagram, but the contribution is coming from different domain experts. Okay, they are experts in their own area, and they develop and they interact each other through web or mailing list or something like that. And finally, they will come up with a usable and the stable software which can be released and which can be used by the end user. Okay, this is how the community works. It's a system, a application developer is expert in application development. But if he goes and develop the kernel, see, just think of one guy who is having all this knowledge. Okay, it is very difficult, right, to do all these things, and yeah, that's why each expert involved in their own domain, and they contribute, and finally it will be integrated on a system, and it will be used as a end device or end application. Okay. So this is the beauty of the community, where, for example, Samsung or anybody like Apple or someone. Apple is not an open source. So, any device, any mobile phone device, they will collect all this information like the application, middleware, kernel, and finally they will integrate. And can you see any advantage with respect to this, guys? I feel like the effort is reduced, and the experts can write the better code in their own domain. And finally, it will be integrated. Even for any company which brings the mobile phone or anything into the market, it will be easy for them because it's already available, and they can just integrate it, and they can do the minor modification on top of that, and they can use it at the end. Okay. So here, the advantages of open source things are like the contribution comes from everywhere. Yeah, everybody contributes, and that will be like a yeah. The growth will be the evolution and the growth will be very good. I mean, they can achieve the stable software with lot of features, and it keeps changing, and new features will be added from different people. Okay, due to the sharing, the development will be faster. And I already told you, if I want to bring a new device into the market, it will be easy for me because it's already available. Many things are available. I just need to change the kernel and drivers for my hardware, and just test it and deploy it. So that's why the Android mobiles came into the market, and they dominated the mobile phone market due to this model. And also, once one person develops a software on one platform, it will be ported across multiple platforms. So again, there is a sharing, and he will customize it, and again he will share it. It's a chain of things, and it keeps going. So the growth is more here. The cost to develop the system also will be very less because they are using the already developed code. Yeah, just think of something where you have 15-20 years of experience, and you got all the knowledge of the open source, and you have made a lot of money, and you want to bring your device into the market. And I really tell you, if you have a good open source knowledge, you can bring it in a very small effort with a small team. Okay, this is the advantage I always keep telling to many people. Okay, so these sessions are very basic, but I just wanted to revisit before going to other things. Okay. Any doubts, guys?
Hello.
Hello.
Yeah, sir. So in the Linux architecture you showed that slide.
Yeah.
Uh, yeah, this one. So from system libraries to kernel modules, everything is in C, right?
System libraries. System libraries can be, yeah. If it's a shared library, if it is written in C, it will be C. C or C++ also. Libraries can be in C++ also, and also there are possibilities of Rust libraries, but kernel will be in C.
So all the kernel and kernel modules are in pure C. Okay. System libraries, it depends on which libraries you are using. Okay. For example, your libstd C++ is part of system libraries. Some part of it is written in C and some part of it is written in C++. Okay. Depends on the
So
library
I
itself.
have. Yeah. So I read somewhere that even Rust language is being introduced into the kernel.
Mhm.
So nothing on that.
Yeah, the
I'm
work is going on, but at this point of time, there is no Rust kernel which is written in C++, or the Rust features are not yet part of the kernel.
Okay.
Okay. See, there is one important thing what you guys need to understand. See, whatever code is written, if you want to write the most optimized code, okay, you write it in the assembly language. Okay, so in C there is a certain level of optimization which can be achieved, and in C++ also there is certain level of optimization which you can achieve. Okay, so whatever you do, the best case scenario is assembly programming. However, you'll not be able to write assembly programming for everything because assembly is not user readable. Correct. So that's why we came up with programming languages like C. Okay, and there were some disadvantages in C where C couldn't support all your inheritance and object-oriented concepts. So these inheritance and object-oriented concepts came into picture because using these concepts, it will be easier to maintain your code. Okay, for any library, be it the system library or the user libraries, for that matter, it is easier to maintain the library if you have written it in a C++, in the C++ programming language. Okay, but if you want a more optimized solution, you can write it in C. If you want even better performance than C, you need to write things in assembly. Okay, so if you want a better performance than assembly, then your hardware should be capable of handling the program. Okay, I can give you an example. Like for example, there are some real-time applications like your real-time video processing applications. Okay, so this real-time processing applications, they use compression algorithms. The compression algorithm can be your RTP algorithm, which is used by YouTube, or the latest compression technology for videos is MPEG-to-TS. Okay. So to achieve a real-time performance for these algorithms, you need to implement these algorithms in the hardware. Okay, that is the best performance what you can get. But there are certain use cases where even with a little lag, it is fine. So in such cases, you can write these algorithms in C programming. Okay. Any questions you have? Nishank, does that answer your question?
Yeah. Yes.
Okay, good. We'll move on.
Okay. So I was coming to the third PPT. This is very basic, okay, but still I wanted to tell you. So executable is nothing but a series of machine instructions which runs on the CPU, and toolchain is nothing but which creates the executable by resolving the dependencies. I mean, we have to add instructions to resolve the dependencies. And yeah, this is what I was talking about the YouTube player. Okay, downloading, demuxing, and playing the audio data on the speaker and playing the video data on the display. Okay, on a mobile, see, today it is fine. We have quad core mobiles and higher end. I mean, quad core CPUs on the mobiles with higher end. When it was in 2008, I think YouTube came in 2008, 2009. Okay, during that time, the RAM was 128 MB on cell phones, and everybody wanted to play YouTube on their phones to make the phone attractive. Okay, so there the hardware acceleration came into picture. So they parallelized all these activities like audio decoding, video decoding, and putting the audio data into display. There was separate hardware modules for this. For example, display hardware accelerator just copies the buffer from the video codec to the display. And for example, video codec hardware accelerator just copies the buffer from demuxer to video codec and give it to the display. So they achieve the parallelism to improve the performance. Yeah, when it comes to the dependency of the libraries here, for example, if I want to write a C code to play the YouTube, I need to interface multiple libraries. For example, downloading, I think you already heard of a curl library. The curl library is specially for handling the URL. Okay, so we can provide the URL to the library and we can download it. And it is something like if there is a 1 hour video, the whole one hour video will not be downloaded in one shot. It will be downloaded with chunk by chunk, like 2-second video, 2-second video, and each video is a link which is loaded, and that will be handled by the curl. Okay, and for example, when it comes to audio decoding and video decoding, there are some special libraries, open source libraries such as FFmpeg and libbaby codec. Okay, so these will take care of the decoding. And when it comes to audio handling, there is a library called also Advanced Linux Sound Architecture Library. It provides some functions, and we can call those functions providing the data. It just writes to the audio device and it plays. Okay. And when it comes to display, there will be display device, something such as a frame buffer or something like that. So what I'm trying to tell you is a YouTube player will have a dependency on all these open source libraries, and each library will be written by their own domain experts. Okay. And yeah, this is how it works. So are you aware of static executable and dynamic executable, guys? Static executable is nothing but a bunch of object codes integrated into executable. I mean, it's a collection of object codes to create an executable where there is no external dependency. And when it comes to the shared executable, second, I'm missing my slide. Okay. Yeah, when it comes to the shared executable, the application will have its own code. Also, it uses the runtime shared libraries, which is shared across the system. So that can be linked while building the executable, and we can link it in a makefile or CMake or something like that. Okay. So I just which is better, guys? A shared executable or can you list out the advantages and disadvantages of shared and static executable just for a discussion? If you are already aware, I just want to tell if.
I think it depends on what is our requirement on that. We require both. For example, if we want to run on hardware or something, if we are making it dynamic executable, then we have to even load the loaders for that purpose. And by default, we can use static flag to run it on hardware. And if you are submitting something to the client, So you have to again share with binaries the loaders and linkers. So static in that case is beneficial, but the drawback of the static is that code size increases.
Yeah, correct. When it comes to the speed, static executable is faster than the shared executable because
Yes.
it doesn't need to link at the runtime.
Yeah, linking is by default everything is present in LF itself.
Yeah. When it comes to the footprint, shared executable is better. Memory footprint. Okay. So this is about the basics of shared and static executable.
Memory footprint as in saving the memory.
Sakshi, right?
Yeah.
Can you come again, Sakshi?
Memory footprint. Saving the memory. Is it something like that?
Yeah, see, for example, what they're trying to say here is, consider we have an application with a main function and 3-4 other source files, because application is not a single source file, it will have multiple source files. And for example, consider this application, it uses libcurl for URL handling, ffmpeg and for video and audio, and lib also for, okay. And consider we have different applications, like 5 different applications which uses curl library. Okay, if I link curl library for all the 5 different applications, statically the curl goes and sits with the application. So each static application will have the copy of the curl. Okay, and if I make it as a shared library, I can have one shared library, and it can be shared across multiple applications. So footprint will be reduced.
Okay.
So let me go to